Hi, in this video I'm going to show you how to solve the hypothesis test problem about the difference between the two population proportions using Excel, okay? So the problem we have is the same one we have been working on, and that's the tax preparation firm, and the firm has two offices. Let me show you the data. So there are two offices and they have different forms they fill out, and no means no error. If there is a yes, then there is an error in the forms, okay? So I want to know if these two offices differ in the proportion of errors they have. So I'm going to use this template to help you go over the problem and solve it, okay? So again, we want to test the hypothesis, and first let's start computing the sample size. The sample size is computed as count A, and then I select the entire column, so 250, this count A, I select everything 300, okay? Number of errors, so I do count if, open parentheses, and then I have to select the range. I do using the keys on the keypad, but you can do using your mouse. And then you type comma, and then Excel asks what is the criteria. The criteria is open quotation marks. You have to open quotation marks and close quotation marks because that's a word, and you have to tell this to Excel. So if you put quotation marks, Excel understands. Okay, so proportion of errors 35, and then count if, open parentheses, and then I select the range for the office number 2. I'm going to use the keys in the keypad, and then I type comma, and then when I type comma on this criteria, I have to type here yes. I want everything that is yes. So I have 35 and 27 errors, and that's the errors we have also on the problem. So let's compute the proportion. Proportion for the first office is going to be equal to this divided by this, and the second office is this divided by this, okay? So hypothesize the difference. The hypothesize the difference is 0. The point estimator for the difference, the proportion difference, is this number minus this number. So the hypothesize the difference is 0. The point estimator for proportion difference is 0.05. Now I have to compute the conditions. Remember the conditions. So the n multiplied by p is equal to n, the sample size, multiplied by the proportion. Has to be higher than 5, and it is. If I simply copy this formula, then it's going to do for the office number 2. Both numbers are higher than 5, okay? Also, what I have to do here is use these numbers to get the pooled estimator. So I'm working on the pooled estimator at the same time. So if I sum these numbers, I have 62, and I have to divide this NP sum by the total sample size. So I divide this number by, open parentheses, the total sample size, which is this number plus this number, okay? So this is the total sample size, and I have to divide this 62 by, so the pooled estimator is 0.11, okay? 0.11. Now what I have to do is, for each office, I'm going to compute the standard error using the pooled estimator, but each office has its own n, its own sample size. So I'm going to do equal 1 divided by sample size equal 1 divided by the sample size. Just to clarify to you what we are doing. What we are doing is going over this formula. The pooled estimator I just did. Now I'm doing the standard error. You see 1 divided by n, 1 divided by n for each one of the samples. Okay, we did this here. So this was done here. Now I'm gonna use this p in the standard error. Okay, you see, first I divide 1 by each one of the sample sizes. Now I'm gonna sum them. Okay, I sum them. Now I'm going to multiply by this part here. But first I'm going to compute it. So the pool using the pooled estimator is going to be equal to this number multiplied by open parenthesis 1 minus this number. Okay, this is what the formula is. That's the pooled estimator. Now I have this, and I'm going to multiply by this. Multiplication of this by this. Now I have to take the square root. Equal square root of this number. Okay, 0.0. This is the standard error. Now I can go back to this formula and do this, or the same thing is this formula. So I get the difference and divided by the standard error. So the z-statistic is the difference, the point estimator for the proportion difference, which is this thing here, divided by the standard error, divided by the standard error. 1.84. Remember, we got 1.85. If we reduce the number of decimal places, that's rounding up 1.85, the same thing we found before. All right, so the confidence level we have in the problem is 0.0. The confidence level is, here is the level of significance, which is 0.10. So I can go directly to here. My alpha, this is the alpha, is 0.10. Sometimes the problem gives you the confidence level, and then you have to start from here, and we went over that in other videos, okay? But because it gives the alpha directly, I'm going to move to up to this point. Now I'm going to divide this number by 2, and I'm going to implement this formula here, okay? 1 minus equal 1 minus alpha divided by 2, okay? Remember we did that. Let me show you on my I did this here, 0.05, 0.95, 0.05, 0.95. This is one of the steps we have, which is this one. Specify the level of significance. If it is two-tailed, divide alpha by 2 and perform the 2 steps. This is what I did. It's a two-tailed, I divide by 2, okay? So critical value approach, let me finish this. So I'm doing the critical value approach. As you see, I got the alpha. Because it's a two-tail, I divide by 2. If it is one tail, you only do for one of the tails. Use it for z critical lower tail in the case of one tail, okay? This one use it for z critical lower tail in the case of two tail. And this is use it for z critical upper tail in the case of two tail, okay? All right, so the z-critical lower tail is equal, remember that? Now we're gonna find the z-critical using these two numbers because it's a two tail. We did that here, we got the z-criticals, I'm sorry, here and here, okay? So the z-critical is going to be norm dot s inverse, and then this probability, and equal norm dot s inverse this probability. You see 1.64 and negative 1.64. The same thing we have here, negative 1.64. So we're finding the same thing because of course it's the same data. We're just using Excel to do it. All right. Now the last step would be I compare my z-statistic, and like my step says, for two-tail, if z-statistic is smaller, 1.5 is not smaller than this, or higher than z-critical, 1.85 is higher than 1.64, I reject the null hypothesis. So I reject the null hypothesis, and I conclude that the two offices differ. Now the p-value in the lower tail. Now using the p-value approach. I got the z-statistic. Now I have to find the p-value associated with this z-statistic in the lower tail. Remember we did that. We have this on the slides. We have here on the slides. Okay. So for the lower tail is equal norm dot s dist z comma 1. In the upper tail, and we have here on the slides too on my steps, two tail, find the p-value, and in the lower tail, use this formula. This is what I did here. This is the same formula. And for upper tail, you do 1 minus this formula, which is the same as this formula. So is equal to 1 minus this number. So if I want to implement, I have to find the smallest of these two numbers. The smallest is this one. So I'm going to multiply by 2 equal this number multiplied by 2. Remember, choose the smallest and multiply by 2. So the p-value is 0.0064, which is the same thing we have on slides 2. 0.0644. Okay? And then now the last step is the p-value. Let's go over my steps. If the p-value is smaller than the level of significance alpha, reject the null hypothesis. The alpha is 0.10. 0.06 is smaller than 0.10, so I reject the null. So this is how you do, you solve hypothesis tests for difference between two population proportions using the raw data in Excel.